Okay, good morning, everyone. Thanks for joining in. And this is the part two of the revision session for ATB for quiz two. So in this session, agenda will be we will cover the basics of week 8, and then we will solve the PYQs. We have got two PYQs, so we will solve them one by one. So I shall just share my screen. Okay, just let me know when my screen is visible to all of you.
Yes.
Yeah, okay, thanks. So before what do? We go to week 8 concepts. So week 8 concept was basically about the motives and how do you find the motives to profile. Okay, so I'll just cover basically first of all the meaning of motive. So the thing is like that we have got some sequences like we have got uh, some T sequences are there. So these are number is T. And in this sequence, what do we want to know? We want to know a k-mer which is present in all and it has got the least score. So idea is that. Okay. And so how do we do that? Now we know that, for example, if there is a sequence and its length is n, then how many k-mers we can make? We can make n minus k plus 1. Okay, so from one sequence. So from this T sequences, how many k-mers are there? They will become n minus k plus 1 to power T. So our search space size is this n minus k1 plus 1 T size is there. And now if we do one by one, that we select one k-mer, then we check it's whether it is matching or not. Then we do one slide, then again we do, then third we do, fourth we do. So that is a brute force. And in this brute force, if we take the complexity, it will become O to power n minus k plus 1 to power T. Now we are doing this n times, and we are for comparing. Now we are comparing k. So if we take this, this will do t times. Sorry. So this will become O2.
23 into t,
Yes.
like n minus k plus 1 into t, right? Like how it will be
No,
solved
no.
out.
2 power t. So these are the number of k-mers which will be checking. So this
Okay, it
becomes
will
n to
compare
power
each and
t.
everything. Okay.
Yeah. So it becomes n to power t to into t into k. So this is a very large number. So how what do we do? We select one k-mer each from every sequence. Okay. One k-mer from every sequence. And this collection of k-mers, one from each sequence is known as motive. So is this understood? Okay. And then what do? We make these motifs which are there. So this is one, this is second, this is third, this is fourth. And now we check their scores to find the best k-mer, which is matching. Okay. So I just wanted to cover what is the meaning of motive, only that. So in this, we have covered this, for example. Now, for example, if we have got like this is a collection of k-mers. So this is the k-mer, second k-mer, third k-mer, fourth k-mer, fifth k-mer, sixth k-mer. So how do we build a consensus string? So consensus string is the maximum frequency of that. So we know that it can have only ACGT. So maximum what is occurring, we take as that. So in that, this will take A, here we'll take T, here we'll take C, G, and G. So question can come also on consensus string. So we can make it. Any question on this? Anyone?
No doubt.
Okay. So now the second, first rudimentary method to solve this problem is known as median string problem. So in the median string problem, what do we do? So we have got a set of sequences DNA. So these are the sequences of DNA, and we are given one integer k by which we form the k-mer. And output is basically the k-mer, which minimizes the distance between this k-mer and the DNA among all k-mers. So we know when we have got a k-mer, we have to build. So it is k times. So it can take only four things, either A, C, G, T, and this is k. So now our search space, this will become 4 to power k. Okay, only these many k-mers can be formed. So initially we are making n minus k plus 1 to power t k-mers. Now we have squeezed that number of k-mers which are possible is 4 to power k only. And now in this 4 to power k, now we do the same that brute force one, that one of the k-mer we start, okay, we take it as a best k-mer, and we get its score. What is the score? And then one by one, we feed all the k-mers, and any k-mer which score is lower, we select that k-mer as the best k-mer. So only the complexity which is now, complexity has reduced now. Okay, this thing is understood by everyone. So now your complexity has become 4 to power k, the number of k-mers which are possible, into n, which is the length of the sequence, into t, the number of sequences, and for matching, for comparing is k. So this is your complexity. Is this clear? Suraj?
Yeah, complexity is reduced. Yeah.
Yeah. Oh, okay. But still, it is a very large size. So this is
Yeah.
about median strength. Okay. So we have seen this concept. Now we
So
come to
I'll
the
confirm once alone. Like
yes, yes,
consensus string, we'll see column wise on there.
yes. So
Okay.
consensus string we do column wise. We select the maximum frequency. For example, A, C, G.
That is
Okay. So this is
yeah.
A. Yeah. Okay. Now we come to the third concept. We have got profile based checking. So what do? We build a profile on the basis of the motives. So this is a motive. So all of them, they are one k-mer from each sequence. And what do? In the first one, in the consensus, we were taking the highest frequency. Here we don't do this. What do? We make a consensus of A, C, G, T from every column. So we find how many times A is occurring, how many times C is occurring, how many times G is occurring, and how many times T is occurring. So from here, we build this profile. This is the profile we get. Okay. And now from this profile, we convert it into now probabilities. So this will become, this number of columns is 10. So this will become 0.2, this will become 0.1, this is 0 and 0.7. So this is your profile based on the probabilities. And now what do? Now you have got this profile from all the motives. Now you can check the probability of a sequence. I'll just select the k-mer with the best probability. So for example, how to use it? If I'm checking for this ACC, GCC, so this is my profile which I've got. So A, I will take from the first column, 0.2. Then I come to C. So C, I will take from the second column. Third C, I will take from the third column. G from fourth column. So benefit of this profile is that at many places you will find 0. So your calculation becomes easy, and in many cases it is 0. And you select the k-mer which has got the highest probability. So that will be the k-mer which will give you the best score. Is this understood by everyone?
Yes, sir.
Oh, so this I have done. So then fourth is the random based profile search. So here what we are doing, so these k-mers which are getting, we are taking one by one. So these are nothing, these are the k-mers. So this is a k-mer from sequence 1, this is a k-mer from sequence 2. So, but again, we have to do so many k-mers search. So what do? We come to a random profile
Most of the
based.
cases it will be zero, right? From the profile based. So
Yes,
computation will become easier, you say.
yes, yes. So then we come to random based profile search. So random based profile search, what do? We randomly make a motif by selecting one keyword from each sequence. Okay. So for example, the sequences were so many and there are so many keywords. So we take one keyword randomly and build its profile. Okay. So we will get something like this, which was earlier. For example, I'll just give you an example. For example, a 3K cable, ACG, AGT, ACC, CGG, CTT. For example, there are only 5 sequences. So we have taken these 5 keywords randomly, and now we build their profile. So here we will get ACGT. So this will become 0.6, 0.400. This is CC, this is 0, 0.4, GG 0.4, 0.2, and here we get 0, 0.4, 0.2, 0.4. Now this profile which is there, now what do? We have got this motif. This is the motif. Now sequence also we have got. So here what do? We have taken one keyword. This is the entire sequence. So entire sequence will have many keywords. 1, 2, 3, 4. For example, I'm taking 1, 2, 3, 4 keywords. And now what do? One by one, we check the score. So we come to sequence 1 and we check. Now we have got the profile. So now with this profile, we check the score of every keyword. And whichever is giving me the best score, now I will select that keyword. So I do here. So my initially selected was this one, for example, red one. But when I checked the score, I found that this keyword is giving me the best score. So I'll select this. Similarly, I do for the second sequence. So my initially selected was this, for example. So here I find, for example, this. So I will select this. I will select this. So probabilistically, what happens, what the professor had also covered, that when you do the random selection of keywords, it is always a probability that out of all these sequences, one of your keyword which you have selected is already having the best score. Okay. So now you have got this. Now you will build. So this is iteration 1 you have done. Now in the iteration 2, what you will do, you will select these keywords which have given you the best score and build a new profile. And again, you check the score and find the best keyword. Now you keep on doing this until there is no change in the best keyword. There is no change in the best keyword. Is this okay with everyone?
Yes, sir.
Okay. So concept is easy. So you have selected one keyword randomly from all the sequences. You have built the profile. Now with this profile, you go to every sequence, you check the score of every keyword, you get the best keyword out of that. Probabilistically, in all the sequences, at least there will be one case where your selected keyword was the best keyword. Now you come to iteration 2. Now with this new motif, now again you do the same. You build the profile and again you check the scores. And this algorithm will stop when there is no change in the keywords. So you have got the best keywords in all the sequences. And once you do all this, so what we were trying to do, so we have found the best keywords with the least score. And now what you can do, you can find from these keywords, for example, you have got ACG, ATG, ACG, ACG, ACT. And now from here, you can make out that which is the keyword which has been mutated the best by doing the consensus. So you'll find from here, it is ACG. So ACG is the keyword, is that position in all the sequences This is the one which is giving you the least mutation score. Is that okay?
Yes.
Okay. Okay. Now, from here to build more randomness in that. So what we are doing in the random based, we are selecting only randomly in the first step. Thereafter, there is no randomness. So now to bring more randomness into this, we come to a funda of entropy of a motif. Okay. So I have skipped like a Gibbs sampling. Gibbs sampling will come from here only. So this I'll cover later. In Gibbs sampling, what happens? So in one iteration, what we were doing here, in first iteration, we were selecting the k-mers for all the sequences. In Gibbs sampling, we do further randomness. So what we do in Gibbs sampling, you select these k-mers which are there. So you have randomly selected some k-mers. And what do you do? One of the k-mer you delete from the sequence. Okay. After once you delete this, so this sequence is having other k-mers also here, other k-mers also. So you have deleted this. Now in one iteration, you only do for one sequence. So you will do only for first sequence with this profile. You find it. Okay. So you do only one change in one iteration. So you have brought more. Second, it brings more randomness by how it does. This deleted k-mers which were there in the sequence, what it does, it will now, for example, there were 7 k-mers here in this sequence, 1, 2, 3, 4, 5, 6, 7. And what it will do with the profile which it is built, now it will select the scores for these k-mers. So now, for example, when you have found the score, there were 7 total, but now you have found out of 7, 5 are giving you 0, and 2 are giving some positive values, 0.012, 1 is giving 0.005. So instead of selecting the best one, what do? You roll a die which has got 2 faces. So now again here you are checking randomly. So you have done what? Okay, you have added more randomness in this. So that is the only difference between random profile based and Gibbs sampling. Is this okay with everyone?
Yes, sir.
Okay. Now, for example, if all these 7 they had given some positive values, then what die you will roll down? With 7 faces. Okay. Now I'll come to this concept. So in the live session, they had covered twice that this question might come. So how we make the logo of a motif? Okay. So I will just take this example on a new page. So now you have got the Gibbs sampler I've covered. I will put it on a new page. Okay, so I will just expand it and I'll explain. So for example, this is your profile. This profile you have got of motifs. So how do you make a logo out of this, and what is on X and what is on Y? So the basic fundamentals in this are, first is called entropy of the motif. So this formula is entropy of the motif formula is summation of minus P of I into log of base 2 Pi. So like for example, for first motif, it will become minus 0.2 log 2 0.2 minus 0.1 log to 0.1 minus 0. So this becomes 0 minus 0.7 into log base 2 0.7. So this gives you a value of 1.147. Now see this formula which is there, minus Pi log 2 Pi. It's what can be its minimum value? Minimum value can be 0 if all are 0. That is the minimum.
Yes, sir.
Okay. And in case it is 0, 0, 0, 1, so then what will be the highest value of this? It will be, or for example, all are having same 1 by 4, 1 by 4, 1 by 4, and 1 by 4. So you can check with the help of calculator. Now the maximum value of this will become 2. Okay. So the maximum entropy of the motif is between 0 and 2. Is this okay?
Yes.
Okay. Now with this, what do we do? How do you make the logo? So I will take this example. So we have taken this example. So this is the example. We have found the entropy. Entropy had come around 1.147. 1.147. So when you make the logo, we know the max height of the entropy can be 2. So here it is 2. This is 2. So here the height of this logo will become 2 minus entropy, which is 2 minus 1.147. And why I am explaining this in detail, so be careful what they are asking on y-axis. So on y-axis, if they ask you entropy, then what will be the height? It will be 1.147. Okay. If they ask you standard logo, how we make, if they have not given, then it will become 2 minus entropy. So now we know that this ACGT which is there, its logo will be 2 minus 1.147, which will become 3945 and 91853. This will be 0.853. So your total height of this logo is 0.853. Now, what will be the size of A, C, G, and T? So G size will be 0. So there is no G. For A will be 0.2 into 0.853. For C will be 0.1 into 0.853. And for T, it will be 0.7 into 0.853. So you take this 7, 5, 35, 3, 7, 56, 59.5. So it will be around 0.6. So you're starting, the biggest number will be, so your ACGT, so your T size will be bigger, and the height of T, total height is 0.595. The second biggest is A. So A is initial, so you can take from here. So your A height will come like this. Then C will be small and G will be 0. So your T is bigger one. After that, you make the next bigger one, which is A. Then you have got C and G is 0. So this is okay. Everybody understood this funda?
Yes, sir.
How we calculated entropy? Can you please?
And entropy, Ulla's formula is minus summation of Pi and log 2 Pi.
From PI will be given.
From here, this is the motive.
No,
So
sir,
this is the profile.
Okay, so
Okay.
can you please just scroll up a little? Scroll
Yeah.
up a little.
So I'll give you an example. Okay. So these are your motives, for example, A, C, G, T, A, C, T, G, T, G, C, G, A, C, G, T, and again you have got A, C, T, G. So these are your k-mers, for example. So what do you do from here? You build a profile. So what do? You make A, C, G, T, and you find the probabilities. So these are 5. So this will become 0.8. C is 0. G is 0. T is 0.2. This is 0. This is 0.8. This is 0.2, this is 0. Here, this is 0, 0.2, 0.4, 0.4. This is 0, this is 0, this is 0.4, this is 0.4. So now what you have to do,
I think
this,
it's 0.6. G is 0.6.
yes, 0.6. So this is, you have made the profile.
G1, sorry, G1. G is 0.6. T is 0.4 only.
So you have built this profile.
Yes.
Now you have to make the logo for this profile. So what do you do? Now you find for every, now you have got these again. You have to build like a profile for this. So you use sigma minus pi into log of 2 pi sigma. So for the first one, it will become minus 0.8 log of 2 0.8 minus 0 minus 0 minus 0.2 log 2 power 2 0.2.
Yes.
Okay, so you get some value, for example. So I just assume, for example, you got a value, for example, 1.2. Okay, just example. Okay, so what do you do now for this this one? So what you will do, you will make like this, and now be careful what they are asking on the y-axis. So on the y-axis, if they tell you that you have to mark entropy, so your height of this will become 1.2 and maximum value of entropy can be 2. It is 0 and 2, between 0 and 2. So if they give you that mark entropy, so your entire height for the logo will be 1.2. If they don't tell you that, okay, you have to mark entropy, then it is 2 minus 1.2. This is the only difference. Okay. And now once you know the logo size, now you come to this ACGT. So you know C is 0, G is 0. So they both will be 0. Highest height will be of A and proportion is 0.8. So your height will become 0.8 into 1.2, which becomes 0.96. So from here till 0.96, A will take. So this is your A.
Sir, why we are only considering first column probabilities only?
No, we have considered all this, no? All four. We are building for this first.
Okay, we are building for this first. Okay.
Okay, now we have got A and now we will get T, rest everything is 0. Now we do same thing for this also. Okay, so this logo will become C and it will become G.
G smaller, yeah.
Okay, now we do for this also. So here now the T will be bigger. It will be something like this and G size will be same like T and you will have C also. Okay, in this case you will have bigger G and you will have T. So this is how you are building the logo.
Understood.
Sir, can
Okay.
you mention how you build the entropy formula, like that equation?
This is given again. So entropy formula is your minus Pi into log of 2 Pi.
Yes. And then
Okay.
how are we substituting the value? Which values are we taking?
So we are substituting these values. So this is one logo. This is another logo. Okay. So your, for example, 0.8, so it will become minus 0.8 into log of 0.8. Then these are 0, so this will become 0, 0. And this will become minus 0.2 into log of 2, 0.2. Is this okay?
Yes.
Okay. So for that, okay, now you build this. Okay. So this 1.2, by mistake, I have made like a same. So these heights will be the different for all logos. This will be the final entropy height.
You mentioned that if they said that y-axis is entropy, then let's suppose the answer was 1.2 for the first logo.
Yeah.
Then we take the maximum height to be 1.2.
Yes.
And if they don't say anything, then we take the maximum height to be 2 minus 1.2.
Yes. Okay.
Okay.
So in the live session, she had repeated again these 3 times that be careful what is represented on the y-axis. So most probably on the y-axis, okay, she will give a change. Okay.
Okay.
Okay, Ullas, is it clear?
Yes, this is clear. Thanks.
Okay. So give sampling we have seen, and the GAs we have come now. For example, consider that we apply brute force motive search to compute the score of every possible choice of gamers in a DNA. Given that DNA consists of T strings of length m, so D strings of length m, what is the total number of different choices of motifs? So I had covered earlier only that number of different choices of motifs. For example, from here, we can have n minus k plus t plus 1 kmers, and total or t. So your search space is n minus k plus 1 t. And from that, when you build a motif, you take only 111 kmer you are taking. So this becomes your n to power t, o to power n to power t. Is this okay? See, here I have got n minus k plus 1. Here I have got n minus k plus 1, n minus k plus 1, n minus k plus 1. And this I can do in t. So from here I am getting 1. Here I am getting 1. So for the motif, I have to select 1 kmer out of this, 1 kmer out of this, 1 kmer out of this. So your total complexity, I can select n kmers and to power t to build different motifs. Okay, the second is we have seen just now this. Consider that we apply brute force motif search to compute the score of every possible choice of kmers in DNA. Every choice. Given that DNA consists of T strings of length n, what is the total number of all possible consensus strings? So we know consensus string 1, 2, 3, 4, k. So consensus string can be 4 to power k. So number of possible consensus string is 4 to power k. Next question, let this represent the minimum Hamming distance between kmer pattern and a kmer in a string. Then what is D, AT, GT, GT, GTA, GT this? So what do we have to do in this question? We have to slide this and to check score at every point, and we have to select the least score. So when you slide GTA, GT, for example, 1, 2, 3, 4, 5, 6, 5, 6. So you'll find the score is 1 here, 1 here, 1 here, 1 here, 1 here. So it is 5. So when you keep on sliding this, so if you come to the last one, it is GTG, TGT. So it is matching at all places other than G. So your score becomes 1. Is this clear? How to find the score? Ullas?
Sir, could you please repeat it one more time?
Yeah. So what do you do? So I'll just take this. So you have to find this. Okay. So what do? You one by one, you slide it. So you have slide it here. Okay, and find the now distance, Hamming distance. So Hamming distance, this is not matching, this is not matching, this is not matching, this is not matching, this is not matching. So Hamming distance become 5. Now you slide it here, A, T, G, T, G, T. So here what will be the score? 1, 2, 3, 4. So this is 4. Now you slide it here. So by doing this slides, okay, you are finding the scores. So what you can do as a shortcut, try to find where everything is matching, which has got the maximum score, maximum matches which is there. So you come here, for example, if you come here and you put ATG, TGT, so this score is your 1. So this is your best place. So this is your score. Is this okay?
Okay, understood.
Now we come to question number 4. Let D-K-mer pattern and DNA is this, where D-K-mer pattern string is defined as in the previous question. Consider a set of strings DNA. So these are strings. Find D distance of ATG to DNA. So again here you do the same thing. You try to find the minimum distance of ATG by looking to the positions. So you see anywhere ATG is there, or dash TG is there, or A dash G is there, or AT dash is there. So we don't find. So here we have got ACG. So this is A dash G. So here score is 1. Now you come to second here directly you got, you don't have ATG, but you got AGT. So here score is 2. Here ATG is there, score is 0. Here you don't find anything. So you will do at TGT, score is 2. Here GTG you select, score is 1, and your total score is 6. Just give me a okay, so we followed the same concept of the previous question just to find this. Now we come to next question. Given a set of T sequences, so these are T, each of length n and an integer k, means your k-mer length is k. What is the runtime cost of the median string algorithm? So median string, what we were doing with this k, we were making 4 to power k k-mers only. We were not taking all k-mers. So we know that only these k-mers are possible. Now with this 4 to power k, when we build these k-mers, so your runtime will be 4 to power k. And now you do the search with every sequence. So you start with n, so it will become n. And now in every sequence, now you will do the comparison at k places. So it becomes k. And you're doing for how many sequences? To t. So your complexity becomes 4 to power 4k into n k t. Is this clear? Complexity 1. Okay, so I'll assume you have understood this. Now next question is, given the profile, what is probability of ATGGC profile? So we had just seen how we do this. So what do? We take the A probability from the first column. So this will become 1 by 2. T from the second column. So this becomes 7 by 10. G, so G third, fourth, fifth column. 1 into 1 by 2 into 4 by 5. And C from last column. So this is 3 by 5. So you can calculate this and you will get the answer. Now during the examination, it is coming in the next question also. Given the profile, given the sequence this, find the profile based most probable 6 k-mer. So these are your 6 k-mers which are given. This is your profile. Sorry. And now for all these k-mers, 6 k-mers which are there, you have to find the score, and whichever gives you the best score, it will be the best k-mer. So shortcut is like that. Now you know zeros where zeros are there. So you know G1, G2, A3, C4 and C5 is 0. So in any k-mer, if you find these characters at those places, straight away you can put it 0. So here, for example, G2 is there, so it becomes 0. Here G1 is there, it becomes 0. Here G2 is there, it becomes 0. Here GTTA, here G1 is there, so it straight away it becomes 0. So now you are left with only 2. So for these two, now you find the scores, and whichever gives you the best score, you have to select that. Is this okay? The shortcut?
Okay. So basically, sir, if G is given in the second place, so we will take G2 at place of that. So we will take the value of G is as 0.
Yes, yes.
Okay.
Okay, so wherever the G is occurring at second place, and we know G at second place is 0.
Okay. Okay.
So we can delete that, eliminate that. Okay. Okay. So with this, I finished week 8. Any question in week 8? Motives, algo, that logo height and all that.
Sir, can you just revise the first part of what you taught right now?
Which one?
The first initial.
initial part was okay, that how you select the k-mers.
Yes, sir. Yes, sir.
Okay, complexity basically. है ना? Okay. So
Co-
see,
and conscience is string.
okay. So see, there are so many sequences which are there. The length of every this is n. So how many k-mers we can form in every this is n minus k plus 1. Is that okay, Bhavya?
Yes, yes.
Okay. So from one sequence, I can make n minus k plus 1. So my search space for all the k-mers becomes n minus k plus 1 to power t.
Yes.
Okay. So if I have to do the brute force, my search space is so much n minus k plus 1 to power t.
Yes.
Okay. So in the brute force, if I have to take one k-mer first out of these k-mers. And now I have to keep on sliding and have to do the search.
So n raised. Okay.
Okay, so this becomes n to power t, for example.
Yes.
So this will become n to power t, n to n I'm doing. And for searching, I have to compare at k positions, it becomes k. And these many sequences, it becomes t.
Okay.
So this is for the brute force.
Okay.
Okay, now we come to the median string. So median string, what we do, we know that all these k-mers which I'm considering, I can make only 4 to power k-mers only.
Okay.
Okay, so instead of selecting all the k-mers, I know that at k places I can take only ACGT.
Yeah.
So this becomes 4 to power k. So everything remains here same, only it becomes 4 to power k nkt.
Okay.
Okay, so this is for your median search.
No.
Like median search is also quite high, because if your k is 4 and your n is, for example, 512 and your t is higher, then it becomes very large. So what from there we came to profile based search.
Okay.
In the profile based search, what we did, that we take this k-mers, so we made a motif. So these motifs are there. All these, sorry, this is one motif, and these are k-mers one by one I have selected. So A, C, C, G, D, and all that. From this, I make a profile. So it gives me probabilities. Okay. And now with this profile, I check every k-mer, and whichever k-mer is giving me the best score, I select that k-mer. Okay. Now, and how do I do this? That now I got the sequences, big sequences are there, so many k-mers are there. Okay. So what I will do, one by one, I will build this motif. So this is one motif. Then I will, for example, this is a sequence. So, and this is a profile which I've made. So this is one sequence. So in this sequence, I will have many k-mers. So for example, will have ACGT, AGTT, ACGC. I'm just giving you a simple example, ATGT. So many sequences are there. Now I pass this profile one by one. Okay. So this profile, for example, when I will pass the profile, I will get the probability for this. I'll get the probability for this. And whichever is giving me the best score, I will keep that k-mer. Okay. Similarly, I will do in the second. I will do in the third. I will do in the fourth. So the probability-based method, which was their profile matching, what it was doing, you were randomly selecting one k-mer from every sequence. You were building a profile, and in one iteration, you were checking for every sequence. So, and probabilistically, professor covered that it is always possible that when you are selecting randomly, that at least one k-mer will be matching your best k-mer. Okay. And in one iteration, you change the k-mer in every sequence. So this was your initially best one, but now you have found this one. Here you have found this one. Here you have found this one. But at least one will match. So in one iteration, you are changing every k-mer except one. Now in the second iteration, again you build that profile with this new sets of k-mers. Again you do the same. So you keep on doing this until your k-mers, they don't change, and your algorithm will converge. Is that okay, Bhavya?
Yes.
Okay. Now the third was the Gibbs sampling. After this, fourth one. So in Gibbs sampling, they have brought more randomness in this. So what you do, initially you do the same, randomly you select one k-mer, you build a profile. So when you, in the Gibbs sampling, one of the sequence, okay, you delete. Okay, you delete and you build the profile with others. So again, you have built the profile. And instead of changing one k-mer in every sequence, now you don't do that. So what you do, you change only the k-mer in the deleted sequence, and that also you do randomly. So what do you do? You have got a profile, you got this probabilities. So now you check for all the k-mers which are there in that sequence. So for example, these 4 k-mers are there, and they have given you some probability 0.1, 0.2, 0.3 or 0.45. Now, instead of selecting the best one, what you do, you roll a dice with 4 face and you select anyone. So this is how you build a randomness in the Gibbs sampling. Okay, so this was the fourth concept. And your fifth concept I had covered in detail was your logo. What will be the logo? Okay. Is that okay?
Yes, sir. Yes.
Okay. So with that, we have finished. So can I take a 2 minutes break? I'll just have a glass of water and then we'll start with the PYQs. Is that okay? Yeah. Okay. Hi, can we start? Yeah, okay, thanks. So we come to the PYQ. Okay, I'll just increase the size. So this is the first PYQ. So this is a question that you have entered an alien world as a renowned computational biologist. The below table is presented to you to as a part of preliminary study done by a group of scientists to study the local fauna. They analyze the DNA and figure out there are only two bases, plus and zero. The below table represents the DNA sequences in 6 positions for different species found. You build a phylogenetic tree that best represents the evolutionary relationship among the species using the neighbor joining algorithm. So this algorithm we had seen yesterday. So the first step, how do we start? We first make the distance matrix from this. So here, if you see this table, immediately you can come to know, or while preparing the distance matrix, that your D and F, your score is 0. It means your D and F, which is there, they have come from the same sample. So what I can do, I can take either D or I can take either F. Okay. So now I build the distance matrix. So A to B, I see A to B. So this is 1 difference, 2 difference, 3 difference. It is same. So the distance is A to B is 3. Then A to D in the similar way I find. So this is matching, this is matching, this is matching. Only this is not matching. So it is 1. A to E, I do the same. I find 3. A to F, I do 1. So this how I build the distance matrix. So this is your distance matrix. Any confusion in the distance matrix? Anyone? This is very, very simple. Okay, so I assume there is no problem. So now in the neighbors theorem, what we have to do, we have to build D star from D. And how do we make this D star? D star formula is D star Ij is equal to n minus 2 into Dij minus Ti and Tj. So this Ti and Tj, they are the row-wise summations. So first you find the T. So for every row, you have got the T. So now I have to build, for example, D star Ij. So D star Ij will become, n is the number of your samples. So it is 4. So this will become 4 minus 2 into D. I have to find D star AB. Okay. So this will become 2 into distance of A to B, which is 6, minus Ti, which is 7, minus 9. So here you will get minus 10. Similarly, you find for all the entries, D star AD is minus 14, D star AE is minus 10. So you find for all. So this is your D star matrix. Is this okay with everyone? How we build the D star matrix? Plus, Bhavya?
Yes, sir. How we calculate what is n? N is 4 now in this case.
Yes, yes. N is 4.
Okay.
Okay. So it is a symmetric one. So you have to just calculate for only these entries and rest everything becomes same. Now the third step is that you have to select the lowest value from this. So lowest value is your minus 14. So this is AD, or lowest is BE. So you can select either of them. So I have selected, for example, AD in this case. And you have to find now delta. Delta formula is, for example, if I have to find delta AD, it is TA minus TD divided by n minus 2. Okay, so delta will become 7 minus 9 divided by 2, which becomes minus 1. The second step is now you can find the limb length now of A and D. So LA is equal to DAD plus delta divided by 2, and LD will become minus DAD minus delta divided by 2. So from here in the neighbor theorem also, we are finding the limb lengths. Is this okay? So your delta becomes -1. So limb length of A will become DAD plus delta. DAD is 1. So this becomes 1 plus -1, 1 minus 1, 0. LD will become 1 minus -1 by 2, which becomes 1.
So
This-
why is it 1 minus -1?
Because the formula is you find delta AD is equal to TA minus TD by 2. So it has come -1 in this case. Okay. Now limb length of A is equal to DAD plus delta by 2.
And limb length of D formula is?
DAD minus delta by 2. Okay.
Okay.
Okay. So now this is first iteration. So in first iteration, you have found the limb lengths of A and D. Now, in this B is also given, so you can use as a shortcut instead of going forward, you can find the limb lengths of B also here. So shall we do it? Take a limb length of B in this?
Yes,
Or I will complete the entire all the steps because okay. Now what you do after doing this, now you reduce this D initially, the D which was there, and you have to couple this A and D in M. Okay. And now you have to find the distance of every point to this M. And the formula is I have to find distance of B to M where M is AD. So formula is distance of B to A, then B to D minus distance of AD by 2. So you get DBM and you have to find DEM only. So when you do this, this your comes here and DEM, you have got this. So in this, when you get this reduced form, whatever the lowest number is there, this is your second combination. And second combination, again you find D star. So you find the total length. This is the total length 5, 5, 6. You find the D star by using the same formula N minus 2, but now N will become 3. So N minus 2 into DBE is 2 minus total distance of B minus total distance of E. This is 2 minus 5 is minus 8. DBM also comes -8. DEM also comes -8. But now we know that B is the 1. So we have to find only for BE. So you find delta BE will become TB minus TE by N minus 2, which becomes 1. So this becomes 0. Delta is 0. So limb length of B is equal to DBE plus delta by 2. And limb which becomes 1. So 2 by 1, 2 is 1. And limb length of E will become DBE minus delta. DBE is 2 minus delta 0 by 2 is equal to 1. So both, now I have got the limb lengths of everything. So now what I do, I start using making the tree. I make first, for example, BE, I put 1, 1, I put AD and D and F for similar. So I put a D and public F. These limb lengths I had found earlier. And I go to original distance matrix and I found only this limb length. Okay, so I go to initial one. So I know that distance from A to E is 3. So A to E is 3. So this is 0 and this is 1. So this becomes 2. And then you can confirm it matches with everything. So in the question they had asked for the length of non-limb. So non-limb is this one. So this is 2. Is this okay with everyone? All the steps are clear, okay? Or shall I repeat the steps again? We had covered it in yesterday revision session.
Yes.
Okay. Okay, we come to the next question now. Next question is, consider the two distance matrices DM1 and DM2. Which of the following statements are true? So the statements they have given that DM1 is additive, DM2 is additive, DM1 but not DM2 is additive, Then third is there exists an ultrametric tree that fits DM1 but not DM2. Then there exists an ultrametric tree that fits DM2 but not DM1. So in this question, they have asked two concepts. First concept is additive tree, and second is ultrametric tree. So first we check one by one. So additive, how we can do by simpler method? There are three methods. Either we can do by additive phylogeny, or we can use also distance based. So we use, for example, distance based. So in the distance based, what we do? We find the lowest distance. So this is 4, 4. So I know that I and j will be in the 1. So rest is k. And now second, I find the distance of AI using the same fundamental which we had covered yesterday. This is k. This point is a. This is I. This is j. So I have to find, for example, AI. So AI will be this plus this minus this. So this plus this minus this. So I get 2 of this divided by 2. So you find this and you get AI is 1, AJ is equal to 3. You put this and then find the last ticket. So here you find that this is an additive tree. It is perfectly matching. Use the same method for this also. So you do 4, 4 and find the distances. So in this, you will get 2, 2. And then you put 4 by for this 6. So we find that both are additive trees. Now, second concept was that both are ultrametric, which is not ultrametric and which is ultrametric, the question. So I used yesterday method only, that how to build the ultrametric trees once you are given. So you find the lowest distance, it is 4 and 4. So IJ will combine and their height will become 2 and 2. Then you reduce this to reduce matrix. So this will become IJ and K. So here the distance will become KI plus KJ divided by 2. So KI is 5, KJ is 7. So this becomes 6 plus 6 by 2 is equal to 6. And this 6 which is there, you take half of this and you make the node, root node height. So this is your root node. K is here. So this becomes 3. This becomes 1 because here it was 2 and 2. So this is 3. This is 2. And you see you have made the ultrametric tree. Any problem in this? Okay, how to build the ultrametric tree from a matrix? Okay, so I consider you have understood. Now, similarly, when you build for DM2 also, you get the same tree. You get 4 and 4. So you put 2 and 2. Then you reduce it. You will get again 6 and 6. You get the same ultrametric tree. So in both the cases, you are getting the same ultrametric tree. So this question for this third and fourth part which is there, I have asked Suganya in the G space. Let me check whether she has answered or not. She has not answered. So if she answers back, I will post in the WhatsApp. Otherwise, for me, only the option 1 is correct. Rest all options are incorrect. Is that okay? Building an ultrametric tree. Okay. Now we come to UPGMA. So UPGMA is a heuristic method by which you build the ultrametric tree. Ultrametric tree. Building using heuristic clustering method. So what do we do in this? So it is a simple clustering heuristic that proceeds by iterative pairwise grouping. In each case, it is true. Given a distance matrix, it starts by grouping 2 taxa with the largest. This is false. It starts with the smallest. The distances between this new composite taxon and all remaining taxa are calculated to create a reduced matrix, which is true. We have seen just now. And the grouping process is repeated and another newly reduced matrix is created. This is also true. So only the false statement is this one, that it does not start with the largest. Concept is understood by everyone?
Yes, yes.
Okay. Then we come to third question. You are asked to construct a rooted binary phylogenetic tree from the given data. You identify 3 tree configurations that are possible: tree A, tree B, and tree C. Based on the information, identify the most parsimonious tree. So they have given a hint also which columns you can ignore. So see, these are 4 samples. At this column, at this column, and at this column, all the entries are same. So we can ignore these columns. So what we get TAC-TAT, CGC-CAT, CAC-TCC, CGA, ACCT. Now to know the best tree, so they have given these trees. Here it is sequence 1 and sequence 2 are matching first, sequence 3 and 4 are matching first. Then we get, and then we do the matching. So how to do this? What we do, we find the scores of every sample with each other. So here we get 1 to 2, score is coming 3. 1 to 3 is coming 3. So 1 can be coupled with either 2 or 3. And 1 and 4 is 5. So 1 and 4 will not. Similarly, we check for 2. 2 to 3 is 4. 2 to 4 is 2. 3 to 4 is 4. So we have found that best is 2 to 4. And best is 2 to 4 means remaining is 1 to 3. So we check here in the diagram. So we have selected 2 to 4 is the best. Then 1 to 3, 1 to 3. So this is the tree which is the best tree, which gives between. Is this understood, this concept?
Yes.
Okay, very nice. Now they have given, you add 4 more sequences to this. How many internal nodes and branches will be modified tree have? So just what we have to do. So this was 1, 2, 3, 4. We have added 4 more, 5, 6, 7, 8. So we know how we do this. So we get one node here, one node here, one node here, one node here. Then we get one node, one node, one node. So internal nodes will be, these are the internal nodes. Okay, so 4 plus 2 plus 1. 1, 2, and 4 is 7. And number of branches, it means the edges. So you count the number of edges, this becomes 14. Is this okay?
Yes, sir.
Yes.
Okay. Very good. Now, the next question is construct a suffix trie for the genome this. Find the number of edges in the suffix trie. Note that single letter $ is not represented in this trie. So please remember the difference between suffix trie and suffix tree. In suffix tree, we condense all this in one, but in suffix trie, everything is there. So I have built this suffix trie. So we start with the AAT, GCC, GT $. So this is the one. And as a shortcut, what do? You find all A's in this. So there is only A here. So the second is this. Then you come to, for example, G or T, for example. So this is T. There is no bifurcation. There is, sorry, T1 bifurcation is taking place here. This is the T1. This is T and one bifurcation here. Then G, so you have covered G here, and there is one bifurcation which is taking place at GT $. And C is single, so name bifurcation, so you get CGT this. So when you count the number of edges, you get answer 32. Is this okay with everyone?
Is it a trie or is it a suffix?
It's a trie, suffix trie. It's a
So
suffix.
Why we are not taking G from the second, only like from T we can extend it to GC, then
No. If you, what are you saying? A from T to come to G.
Like it's A, G. So A we are extending it from the first branch only, then T we can extend it from the second branch also.
Okay, just hold on. So I'll just understand. ये है, तो आप कैसे करते हैं इसको? ये है आपका. This is the one you have to build. So what do? First, so how many combinations are there? AAT full is there, first one. Then second is your ATGCGT dollar. Then you have got TGCGT dollar. Then you have got GCGT dollar. Then you got CGT dollar, GT dollar, and you got T dollar. These many you have to build for the
Yes, sir.
genome. Okay. So what you do, first you start with the first one. The first one will become your full. A, T, G, C, G, T dollar, and put the notes. Okay, ये बन गया हमारा.
Yes,
Now
sir.
second, so we have covered this. Now we come to this one. So now we know that A is already there. So I can bifurcate from here and I will make T, G, C, G, T dollar. Okay. Now I come to TGCGT. So T is not existing, so I have to build new one. So this will become TG.
So T is there, no? T is there.
No, I cannot branch from here because now it will not match with this, no? I have to build this.
Okay. Understood.
Okay.
Understood.
Okay. So yeah. Okay. So next question, they have asked the number of edges in its tree. So now they have used the word tree. So now you know that this entire thing, this A which was there, it was bifurcating into two. So I put A here, rest everything can be represented by this. This can be represented by this. Similarly, T, it is bifurcating at 2. So one GCCT dollar and another is only dollar. Similarly, G, it is bifurcating at 2. So I get CGT dollar, T dollar. And C, there is no bifurcation. So it straight away can be represented as CGT dollar. So if you add the number of edges, you get 10 for this. Is this okay with everyone? Surupi?
Yes, clear.
Yeah, okay, good. Now we come to next question. Consider the following inverse Burrows-Wheeler transform problem. For some text, we have BW2 text is TGC$C. So this is the last column. Yesterday we had seen. So this is the encoding. And how to reconstruct the text from the provided Burrows-Wheeler transformation. So there is very simple trick. What do you do? This is your encoded form. Now you know that this encoded form has come from alphabetically ordered first column. So you do alphabetically sorting of this and you get the first column. So first dollar will come, then C1, C2, G1, T1. So this is the only trick. And now you start with dollar. So here I take dollar. Now I see which is the before dollar, what is there. So it is T1. I come to T1. So T1, before T1 is C2. I go to C2. C2 before is C1. I go to C1. C1 before is G1. And before G1 is dollar. It means it has finished. So I get G1, C1, C2, T1, which is GCCT dollar. Okay, so we can do it. It is easy.
Sir, can you repeat this one more time?
Yeah, okay. So I'll take this. So this is your BWT. So BWT text means that this is your last column. So this is TGC$C. Now I know that first column is alphabetically sorted and it will contain only these characters.
Yes.
So I do the alphabetically. So dollar C, C, G, T I get. And now I'll do the numbering. T1, G1, C1, dollar is always one only, C2. And I do the C1, C2, G1, T1. Is that okay? Now I start.
Yes.
Now I start with dollar. I put dollar in last. So I know this character which is there, which it will come before dollar. So I got T1. Now I come to T1. T1 before is C2. C2. I go to C2. I get C1. I go to C1. I get G1. I come to G1 and it is dollar. So I stop it here. So answer is GCCT dollar. Is that okay?
Yeah, no, it's okay.
Cool. Now, next question is, which of the following represents the correct output of constructing the Burrows-Wheeler transform PWT text for the text? So this is the text and they have asked us that what will be the encoding. So what I'll give you a small shortcut. So these are the choices they have given. Okay. So when you do the Burrows-Wheeler transformation, you know that in the starting only you have to do alphabetically sort. Cut. We have to do this with starting from dollar. So first I know that first will be dollar TAAT, and if I take the dollar here, so last will come T. Now the second alphabetically order, whatever it will be there, it will start with A. So I try to find all the A's. So here it is AAT. Here it is ATG. ATGG. Here it is ATGT. So I know that this one will be the first one. So I make with the AAT and I make the full sequence. AAT, GCC, and in last, if you see what it will come, if it is AAT, it will be $T, or it will be, yes. What will be the here again? Again, it will be T because the last this T will come. Now I come to ATGG and ATGT. So first will be ATGG. ATGG is where? ATG, it was ATGC, sorry. So now I come to ATGC. So I build with ATGC. And I see in the last what it will come. So if you start with this ATGT, this dollar and TT, they will come here, or it will slide in this direction. So you get this one. So you are just seeing this third part, and by doing this, you can eliminate all other things again. So you will get again this TT ACG. So here it will come, and you can select that. Is this clear with everyone?
In the third row, what will be the last element?
Last element you have to slide again. Okay, so third element, see, I had done here. So if you do AATG, CATGG, ATGTT, $T. Okay, now you start with ATGC, your last element will come A. This A will go there.
Okay, we keep rotating and then we, for the answer, we only look at the last column.
Yes. So this is your, because already we are doing alphabetically sort while doing this.
In the last column, it starts with the dollar sign. We do not consider that, right?
Yes, we don't consider. We will consider from here only.
Okay.
Okay.
If dollar sign comes somewhere in the middle, maybe not at the start of the last column, somewhere in the middle, do we consider that, right?
Yes, it will be considered.
Okay.
Okay, so this was a short trick. Okay, then we come to k-means. So select the correct sequences of k-means. We had seen yesterday k-means. What do? First, we select the centroids. Then we check the distances of all the points to these centroids. Then we give responsibility that this is to this, this is to this. And fourth point is that now you update the centroids. So you see, first is the initialization of cluster centroids. Then you do distances of each one to centroids. Then you do the assignments of the data points. And fourth, you do updation of the cluster. So it is easy. Just go through yesterday's session. Then is the k-means clustering method is prone to give erroneous results. So in which of the following cases that the color here represents a ground truth clusters? So in which case it will give errors? It will give errors here. It will give errors here, but it will not give error here because it will make these three clusters. Okay, but here again it will give errors. Is this okay?
Yes.
Okay. Next question, we had solved this question yesterday. It is directly from the GA that there is a hard k-means clustering problem. There are 4 points and there are 2 centroids. And after how many iterations will the algorithm terminate and what will be the final centroid? So we use the same methodology. So this is center 1, center 2. So iteration 1 will be assignment. We find the distances of every point and assign the responsibility. So we find distance of 1 to first cluster is 2, with the cluster 2 is 18. So your responsibility of first point is towards first cluster to 1. Similarly, second point also belongs to cluster 1, but third and fourth ones, they belong to cluster 2. So now you come to the second step of the iteration, which is update. So C1 will become 1, 1 plus 2, 1 divided by 2. C2 will become third point plus fourth point divided by 2. So this is the 1. Now you come to iteration 2. So in the iteration 2, what you will find that your first point and second point is 2 with the cluster 1. Third point and fourth point are with the cluster 2. So there are no changes in assignment. And if there is no change in assignment, then there is no update of cluster, and therefore the algorithm converges. And your final answer is iteration number 2, and clusters are 1.5, 0.5, and 4.5, 3.5. Is this okay? This k-means we have seen many times in our previous courses. Any question on this? Anyone?
We have the points, and we just for the first step we are just calculating the distance between the point to each center, and then we are finding which is the closest one, and we assign that point to
Yes.
that cluster,
Yeah.
right?
So there are 2 steps. Okay, one iteration. There are 2 steps. One is assignment, and second is update of clusters. Is this okay? Assignment, how do you do? Measure
Find
distances,
yeah,
measure distance,
smaller distance.
and assign. Okay. Update means summation of all the points, this Rn into Xn divided by R. Okay, or summation of Rk. So for example, we had 2 points which are assigned. So 1, 1 was assigned and 2, 1 was assigned. And how many points were there? 2. So your cluster 1 gets to 1.5 and 0.5. And for the second cluster, the points were 4, 3 and 5, 4. So it will become 4, 3 plus 5, 4 divided by 2. So this will become 4.5 and 3.5. And when you come to iteration number 2, then there is no change in assignment. Therefore, there is no update. And the algorithm converges. And you get answer 2 iterations and 1.5, 0.5 and 4.5, 3.5. Is that okay?
The last iteration where there is no more shuffling,
Yeah.
we consider that in the count of the number of iteration.
Yes, because you're checking, you're carrying out that
Yes.
iteration.
Yes. Okay.
Okay.
And this 1.5, 0.5 is the new cluster, a new centroid for cluster 1, right?
Yeah, yes. So this is cluster 1, this is cluster 2.
Okay. Okay.
Okay. So I had solved till here only. Now we see other questions of this. Okay. Now we see this question. So given the data points in the previous question, so data points were, just let's see what are the data points. So data points are, okay. So data points are 1, 1, 2, 1, 4, 3, and 5, 4. And now they have asked us that we want to use the vanilla soft k-means instead of hard k-means. Let the stiffness parameters beta be 1. Then in the first iteration, where the centroids are C100, C244, what is C1 and C2's respective responsibilities for the data point 1, 1? So yesterday we had seen the responsibility of R to the cluster K, R1.1, is equal to, it will have two responsibilities. It will be e to power minus beta d1 plus e to power minus beta d1 plus e to power minus beta d2, and R, this will become 1, and R21 will become e to power minus beta d2 divided by e to power minus beta d1 plus e to power minus beta d2. This was the formula. So in the first iteration, now you see the C1 is 0, 0, C2 is 4, 4, point is 1, 1. So first you calculate D1 and D2. So your D1 will become 1 plus 1, 2. This will become 4 minus 1, 3 to power square 9 plus 9, 18. Is this okay? This is step. So responsibility to first cluster will be beta is 1. So e to power minus 2 divided by e to power minus 2 plus e to power minus 18. And responsibility to the second cluster will be e to power minus 18 divided by e to power minus 2 plus e to power minus 18. Is this okay? This Surupi?
Can you mention the points one more time, how the values are coming?
Okay, so these are the points 1, 1, 2, 1, 4, 3, and 5, 4.
Yeah.
Cluster 1 is 0, 0. Cluster 2 is 4, 4. You know that distance is equal to x2 minus x1 square plus y2 minus y1 square.
Yes.
So you get the distance of first point to first cluster is 1 minus 0 plus 1 minus 0. It is 2.
Yes.
Distance with 2 is 4 minus 1 to power square is 9 plus 9, 18.
Okay. Yeah.
Okay, so you got the responsibility to the first cluster and second cluster
Oh, you're just putting it in that equation.
in that equation. And beta they have given 1. And what you can do, if you divide this entire everything by e to power minus 2, so this will become 1 plus e to power minus 16.
Yes.
And this will become e to 1 divided by e to, here you are dividing by e to power minus 18. So this will become e to power 16.
Yes.
Okay, so this will be your answer. Let's check this answer.
Okay.
So they have given 2 root 2 and 2 root 2. So what they have used again, the distance formula is your this root formula. Okay, I was using that formula. They have used the formula this.
Will we always be using this under root formula?
Yes, in this question they have used.
Okay.
So this will become root 18. We can write 3 root 2. Okay. And then we can just find the answer. So this will become 1 plus 1 plus e to power minus 3 root 2. And this will become plus root 2. This will become e to power, 1 divided by 1 plus e to power minus root 2 plus 3 root 2. So this will become 1 plus e to power minus 2 root 2 and this will become e to power 1 plus e to power 2. Okay. So this is the answer. Okay. So our answer is matching.
Yeah.
Okay. So what we have learned again in this, we have learned again that distance we have to calculate the root of x2 minus x1 square plus y2 power minus y1 square is equal to d. Okay. So we have to calculate d like this. Only that. And this concept we had seen yesterday. Okay. So this formula we can remember easily. Shall we attempt the second question? Another next question? Okay, this was the last one. So shall we solve the another PYQ, sorry?
Yeah.
Okay. Okay, so next one is where somebody had shared this in ATB. Okay. PYQ is here. Okay, so we have to do the fill in the blanks first. Okay, and let's understand this step by step. Okay, so see, we have seen the neighbor joining. Neighbor joining, what do? First we find T, then we find D star. From D star, we take the lowest, and then we find delta. So delta we have come, and then we find limb length of I and limb length of J. So limb length of I was D of Ij plus delta by 2, and limb length of J was Dij minus delta by 2. Is that okay? So here that will become
Yes.
in the fill in the blanks. Okay. So let's check again. So see, the same has come. Okay. So we are right. Our fundamental are clear. Is that okay?
Yes.
Okay. Now we are given a next question. Okay. You are given a set of T motifs, each of length n. Each of length n. You are also given a k-merge sequence k is equal to T. K-merge sequence. Which of these quantities do not have O to power nt complexity? So we have to check one by one. So without saying the answer, let's check. See, so what they have given us that this is a set of motifs. The length is n. Set of motifs means that this is also a motif. 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 And a set of T motifs, each of length n. Set of T motifs. So this is n and this is T. You are also given a k-merge sequence k is equal to T. That k-merge sequence k is equal to T motifs. So this they have given k is equal to T. Which of these quantities do not have O to power nt time complexity? So score of motifs, if we check, we are checking n one by one we are checking, and how many we are doing? We are doing T. So this will be O and T will be there. Is this okay? When we check the scores, see, we are checking score of the motives. So we are checking this score. So this will be T into N only. We are checking scores of motives. So this will be ONT. To build the profile of motives, we have got N and we have got T. This will also be NT. The consensus which is there, consensus will also be ONT. Only probability of sequence to profile of motifs we have to do for all, for the entire sequence, and this will become N square T. ON square T. So this is the only one which is not matching. Everything is matching. Okay. Now we come to this question. This is a question from maximum likelihood. Okay. We have given find the MLE of the parameter beta of a population having density function fx beta is equal to 2 by beta square beta minus x. X is between beta and 0 for a sample of unit size n is equal to 1 with a being the sample value. So if a is the sample value, this will become fa to beta is equal to 2 by beta square beta minus x beta minus a. This is the one, first one. And for MLE, what we do, we take its derivative with respect to beta. So this will become, I can write down this as 2 by beta minus 2a by beta square. And when you take the derivative, it will become 2 into minus 1 into beta minus 2 minus 2a into minus 2 beta minus 3. Is this okay? This one? Derivative?
For the MLE, we take the derivative of the function with respect to beta.
Beta. And then we equate it to 0.
Okay.
Okay. So because we are doing the maximum likelihood. Okay. So at the maximum, the derivative will be equal to 0. So now we can put it as this will become minus 2 upon beta square. This will become 4a by beta cube is equal to 0. And if we solve this, this will become minus 2 beta plus 4a is equal to 0. And beta is equal to 4a upon 2 is equal to 2a. So in MLE, what we have to do, we have to estimate this beta, which was unknown. So we have got beta is equal to 2a. Let's check the answer, whether it is matching. Beta is equal to 2. It is correct. I think this same question is there in the GA also, if I'm not wrong, because I have seen this question earlier. Anyone? Bhavya? Okay, so we just remember the steps here for the MLE. Steps that you, for maximization MLE, you take the derivative with the beta of the function and equate it to 0 to find beta. Is that okay?
Yes, sir.
Okay. Okay, now we come to next question. It is the same question, if I'm not wrong. We have solved it.
The table looks the same.
I know, but let's see it. Just a table को ही देख लेते हैं पहले. तो जहां पर भी 5 आपकी एंट्री आई ना, तो पहले जस्ट ट्राई टू एलिमिनेट वन जो कि सेम टू सेम है. तो यहाँ पे देख लेते हैं कौन सा है. So see, we will find the distance matrix A to B. How to check? 1, 2, 3. So this is 3. A to C 0, 0, 0, 0, 1. Only 1. A
Sir,
to
how we are counting this A to B is 3?
C, A to B, these are not matching. This is not
Huh?
matching. This is not matching.
Okay,
This
okay.
is matching. This is matching. This is matching.
Okay, okay.
Okay.
Yes.
Okay. And now try to find. So we have found A to, now find A to D. A to D, this is matching. This is not matching. 1, 2, 3. And A to E, this is matching, 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 not matching. 1. So we have got this. Now we try to find B to C, because we have done A to B, so we have done. So B to C, C 1, 2, 3, 4. B to D 1, 2. B to E 1, 2, 3, 4. Now we come to C to D 1, 2, 3, 4. C to E is 0, 0. So immediately we come to know that C and E are same. So we can take either one of them. Okay. And now we come to D to E. 1, 2, 3, 4. So this becomes now what we build like a distance matrix. So your distance matrix will become A, B, C, D. E we are eliminating because it is same. A, B, C, D. A to B 3, A to C is 1, A to D is 3. B to C is 4, B to D is 2. Now C to D is 4. So you have calculated this. Okay. Now from here in the question, they have asked a table below. The scientists have tried to construct the distance matrix as below. So first is the distance matrix. Okay. So distance matrix आप check कर सकते हैं. Then which among the following represent the corrections you have to make. Here D, X, Y. Your task is to verify if the distance matrix is correct, and if there are wrong values in the matrix, then substitute with the correct values. So this is directly from the distance matrix. Then use the correct distance matrix to compute the following limb length of B. Okay, so we have to find the limb length of B. So how do you find the limb length of B? Limb length of B is equal to minimum of, now see, I had explained this concept yesterday also. So this is B. I don't know what is there here. Here it can be A, C, or D. Here it can be A, C, D. Here it can be A, C, D. So limb length is minimum of this plus this minus this divided by 2, and check for all the combinations. So this will become minimum of AB plus, I am taking AC combinations, BC minus AC by 2. Or if I take, for example, CD, so this will become CD plus BD minus, sorry, this will become CD plus BD minus CD divided by 2. And now I take A and D combinations, so it will become AB plus BD minus AD divided by 2. Is this clear, this concept, Lakshman?
Yes.
Okay. So now you start fitting this, okay, from your distance matrix. So distance matrix we had found. So this is B. So this will become minimum of AB. AB is 3 plus BC is 4 minus AC is 1 divided by 2. So this is 3. Now it is BCB. CB, BC is 4 plus BD is 2 minus CD is 4 by 2 is equal to 1. Last one is AB 3 plus BD 2 minus AD is 3 divided by 2. So this also becomes 1. So your min length of B is how much? Is equal to 1. Is that okay?
Yes, sir.
Okay, let's check the answer. So answer is 1. We are correct. Okay. So our understanding is correct. Okay. Now is the question. This is the question. Scientists have constructed the following phylogeny using the additive phylogeny algorithm. The algorithm chooses the leaf A in the first iteration. Chooses the leaf A in the first iteration, the leaf B in the second iteration, and the leaf C in the third iteration. Which among the is or are correct about the weights of the edges in the phylogeny? So, how did we do the additive phylogeny? Can somebody tell me?
We picked the smallest distance and made them into a pair. Like that. No?
See, that was the distance based. That was distance based.
Okay.
Okay, additive phylogeny, if I'm not wrong, it starts with the limb length. We find the limb length. So what he has done, the algorithm chooses the leaf A in the first iteration. So it has found the limb length of A first, okay? Then leaf B in the second iteration, leaf B is the second iteration, and the leaf C in the third iteration. So these are the limb lengths which it has found. Shall we see that additive phylogeny ka pseudocode, or first we see the choices what they are asking? So it's a simple question they're asking.
Do we need to find the limb length of ABC, all three of them?
No, they have just given one. This is a new question, no relation with the earlier question. They have written that in the additive phylogeny, they have found leaf A, leaf B, and leaf C in the third iteration. So it means first they found leaf A ka limb length, then they found leaf B ka limb length, and then they found leaf C ka limb length. Okay. So, but just hold on. This A, B, C, D, E, F, G, H, though they have not given anywhere. So how to find this question? Anybody any idea about this?
No, sir.
Jagan?
He is not here.
Okay, Jagan is not here. Okay, so we'll leave this again. We'll not waste time on this. I will try to find an answer for this and I'll post on the WhatsApp. Okay.
Sure, sir. Sure.
Okay. Okay. Now is the question. Next question. We move on. So I'll put some space for this and I'll post it here. You are asked to construct a suffix tree of a DNA. So it is a suffix tree. If the alien DNA is composed of 6 different types of nucleotides, then what is the maximum number of children a node can have in the tree? Assume the symbol $ is appended at the end of the sequence. So if there are 6 different types of nucleotides, so what it can become, it means that from every node, you will have 6 different nucleotides.
Hmm.
1, 2, 3, 4, 5, 6. So as per the understanding, it should be 6.
Yes.
Okay. Now, let's check the answer, what they are saying. He's saying 7. Assume the symbol star is appended at the end of the sequence. So they are considering that dollar also, which is there, last dollar which is there, that also they are considering. Otherwise, generally we don't do this. It is not done. So they are just, they have given in this question. Okay.
Okay.
Okay. Okay. Now let's go to next question. If a genome sequence text of length 100 takes 400 bytes of memory space, then how many bytes of memory space is required to store the Burrows-Wheeler transformation of text? It will be same. Burrows-Wheeler transformation, it changes only this part here, but the number of entries, they remain the same.
Hmm.
Okay, so it will be 400 bytes only.
Yes. Yes.
Okay, yeah, that's it, the answer. Yeah, so it's correct again. So our understanding is correct. Okay, you join a job that involves working on samples read for disease X. The figure given below represents the suffix tri of the reference human genome for a healthy sequence. Based on the above data, answer the given sub-questions. We say a person S does not have the disease X, that is S is healthy, if the sample read collected from S does not have any mutation. The options given below are the reads collected from different individuals. Match the reads with the suffix tri to identify which among these are healthy. So it is nothing but okay, you just have to match. So I'll just copy this and try to match here. Or shall I leave this question? We can do this again. It is an easy one. Just try to match whichever is matching. There is a mutation has taken place and he's not healthy. Whichever is not matching, it means the mutation has not taken place. Or let's copy this. This is quite a big one. So let's first understand the question. What's the meaning of healthy and unhealthy? The job involves working on a sample reads for disease X. The figure given below reflects the suffix tri for the reference human genome for a healthy person. We say a person does not have disease. This is the important part to understand. Okay, so we write it here. We say a person S does not have the disease, that is healthy, if the sample read collected from S does not have any mutation. Does not have any mutation means it should match. It will match, then only it is healthy. It is a meaning this same only, what I'm understanding.
Yes, sir.
Okay, so if it will match, then it means he's healthy.
Yes.
And
yes.
now let's check one by one that which are matching and which is not matching. Which is a perfect match and oh, thank you. Which is not a perfect match. So we start with C, C, G, G, G. So we have got C, we got C, we have got G, we have got G, and we have got G. So till here it is matching. So this is a match. Then we check CCGGT. CCGGT. So it is not matching. So this one is not matching. Then we match CTAAC. CT, there is no T. So here it is not matching. Then we check TCAAC. So we go to T, T, C, A, C. So this is matching. Then we come to A, T, C, C, G, A, T, C is not matching. So this is not matching. So these are the ones where the mutations, they have not happened and they are happy. They are healthy. Is this okay? This concept?
Yes, sir.
Okay.
The ones that completely match, those are the healthy individuals.
They are the healthy individuals. It means okay, there is no mutation which has happened.
Okay.
Okay.
And this suffix tri is also from a healthy individual.
Yes, yes. So they have given in the question that it is from a healthy individual. Okay, let's see now. Now use the suffix tri given to determine which among the following is the reference human genome for a healthy person. So again, we have to match only. Again, we have to match only. But in this now, they have given a dollar. Which among is the following is the reference human genome for a healthy person? So we start, for example, this TTGTCC. So we know that T, there is no T here. So here only it does not match. This does not match. We come to this ATG, T, A, where is A is here. A, T, G, T, then GTC, A, C, C, G, 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 T, and dollar. So this is matching. This one. Now the another one is TT. So TT though we have seen TT is not matching. Now if we see ATGTCAA, so this will not match. Where it
Last
will,
one is G, that is not there.
this will not match, है ना?
Hmm.
This will not match. So this will not match. So just we have to match here, and all dollars are there. So we have to match up to last here. Okay.
Okay, sir.
Yeah. Next question. Let's see.
This paper is relatively very easy.
This one. Yeah.
The
Every
last
term,
paper had so many calculations.
I
This
think
paper is easy.
every term they are increasing the difficulty level. I feel so.
No, this is latest.
This is latest. Okay. 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 Now we have to calculate. Calculate score of motives. Score of motives. Okay. So how do you score of how do you calculate a score of motives? Anyone? Have you done that question? Score of motives. I know the probability that this score will be this one. Probability this, and probability this. This is the score. Should be of this motive or this is the motive. Let's check how this is 16. The single integer. Shall we see our notes again for this? What is the score of motives? This is the week 8. So score of motives. We've seen Gibbs sampler. Size we have seen. Entropy we have seen. This we have seen. Randomness we have seen. This is the probability of the profile. Score moving gamers. This. Shall we ask ChatGPT this question?
Yes, sir, we can do that.
Yeah. Okay. So ChatGPT has not given the correct answer, but it has given one hint, I guess, which we can use. So see what it has given. This is a set of motives, 10 motives. It means the first one which is coming here, this is 1 by 10. It means A is 1 here, and
Yes.
C is 2, G is 6, and T is 1. In the next one, it is 4, 0, 6, 0, 0, 0, 10, 0, 10, 0, 0, 0, 3, 5, 2, 0, 0, 0, 3, and 7. So if we compare again and try to build the logic, so it will be like this, that first motive is like this, first motive, second motive, third motive, fourth motive, and the score which is there, score is that there are how many differences are there that from the here. So how to build, we had seen that row wise also we could do. So the ChatGPT, what it has said, that it will be 6 minus 1, it is 6 minus 0, it is 10 minus 0, but it is not matching. Those answer, I don't know why it is giving 6.
Is it taking the count of G, that is the highest probability in each row?
No, answer it is giving 16.
Okay.
Okay, so score is generally, what is the score? A, T, G, C, C, and this is A, T, C, G, G. So score is 3. है ना? Score का meaning तो यही होता है. But how can you make out that okay, here the score, what will be the score? If you are given the this, so it is just giving you that in this column, these are this many entries. These are A, these are many C's. Okay. This also we just skip. Okay, I'll try to find the answer for this. Okay. Find the consensus of the motives. Oh, this is based on the same question. The profile matrix, this one is easy, but find the consensus of the motives. Consensus of the motives.
This one is maximum value from.
This one consists, so we can take directly from here.
Maximum value from.
So yeah, G, it will become G, 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 A, C, T. And consensus. You take the maximum. But now, okay, shall we try to find the score with respect to this? Okay, now, can we do that? But how we'll do that? How this 16 is coming, I'm not understanding. There was a clue that okay, that you find row wise, the answer will come the same. How to find this? You can make a consensus, then find the score, but then also you can find the score. Okay, this first one, okay, I will try to check. Okay. So this is correct again, and this is also easy. Profile matrix to check this. So what you do, you just find the probabilities of this. This we have seen in one more question. So just use the probabilities. So here again we know. So we'll say use the same concept. C2 is 0, T2 is 0, A3 is 0, C3 is 0, T3 is 0, then C4 is equal to G4 is equal to T4 is equal to 0, T5 is equal to 0, A6 is equal to 0, and C6 is equal to 0. So straight away we can eliminate all that. So try to find that C2. So C2 is 0. So immediately we cut this. Here C2 is 0. Immediately cut this. Then your G4 is 0. C3 T last is 0. Here in this, what is there? AGG. AGG. So it is matching. A4 is matching, but C4 is 0. A4, C5. So this also 0. This GGG, A4 is 0. So A6 is 0. So this cut off. So this only remains here. So by using this shortcut, you can easily compare it. Is this okay?
Yes, sir.
Okay. No, the K means this is the same question. We can do this. We have solved it. So I will not solve it again. Okay, we can do this question.
Yes, sir.
Yes.
Okay, then we go to next question. This is the last one, which is the following is this. So we will try to see one by one. Okay. Okay, which of the following are true? K means algorithm requires the initial centroids to be chosen randomly. Yes. K means algorithm may not find the globally optimum solution. True hai, it only finds the local. The complexity of the K means algorithm is polynomial with respect to the number of data points and clusters. इसका देखते हैं. And K algorithm can be used for clustering data points in higher dimensional space. No, because then your calculations becomes NP hard. So is this correct that K means algorithm requires the initial centers to be chosen randomly? This is true. We have seen from our earlier courses also. These clusters which we are selecting, they are selected randomly.
Yes.
Okay, so this is also true. The complexity of the K means algorithm is polynomial with respect to the number of data points and clusters. This I am not sure because this is a NP hard problem. So generally when we see polynomial, so let's see the answers what they have given. Okay, so all are correct.
What does it mean by clustering data points in higher dimensional spaces?
Higher dimensional spaces means that till now we have seen only single dimension like 1, 2, 3, 4, 5, 6, 5, 6, 7, or we were doing 1, 1, 1, 2, okay, or 4, 5. So this is 2D. Now when we increase the dimension, so for example, you have got a point like this 1, 1, 2, 1, 2, 1, 2, 1. So then it becomes a NP hard problem.
Because there are many points, many dimension for one point. So you have to find multiple times.
Yes. So see, he has to calculate the distance with one cluster point.
It will just become very tedious, right?
It becomes an NP hard.
Okay.
So that's why when they are using it cannot be used again. So this is false. So this is true. This is true. This is false. Okay, may not find true hai. The K means algorithm may not find the globally optimal solution. This polynomial. So I don't know why they have given the second option, because may they are playing with English, that may or may not find. Okay, rest all options are same. Otherwise, generally we say that K means okay, find the local optimal solution and cannot find the global optimal solution. Okay, so this is a point of contention. We can deliberate on this. So there are 2 questions which are left. I will solve them, and maybe within half an hour I'll post on WhatsApp. Okay, is that okay?
Yes, sir. Sure.
Okay, otherwise we have seen the concepts. So go through the concepts again and try to use those concepts. What I feel the question paper will be 20% will be tricky. And we have not seen those exercises of that book. So we have to just go with our concepts and the other questions. Okay.
Sure, sir.
Yeah. Chalo, thank you very much for joining in and have a nice day and all the very best for tomorrow's exam. Yeah.
Thank you, sir. Thank you very much.
Thank you so much,
Thank
sir.
you.
Yeah. Okay. Bye.